Good evening from the Philippines, or good morning from wherever you are today. I am Philip Richard Sunica. I am a lab expert at the Standard and Interoperability Lab for Asia. I am here to have the second part of my webinar series entitled Development of a Proof of Concept Health Enterprise Service Bus for the Philippine Health Information Exchange. Just to give our new listeners a background, as part of the AeHIN, I am giving a series of talks with regards to our experiences while implementing the prototype for the Philippine Health Information Exchange. The Philippine Health Information Exchange is a project of the Department of Health of the Philippine Department of Health, which aims to integrate and make interoperable all the health systems in the country. 2 weeks ago, I gave a talk on benchmarking health enterprise service buses that will be used as middleware or interoperability layer for AeHIE. For today, I will be giving a talk on the requirements and architecture that we had in implementing the prototype. Take note that for this prototype, we are only focused on the primary healthcare workflow. We will discuss in a while what are included in this workflow. However, the architecture will still be based on the full implementation of the Philippine Health Information Exchange. The following will be the outline of the talk. Take note that this will be a short 30 to 45-minute talk, so this should not take much of your time. For the outline of this talk, so the first part of the talk is a discussion on the use cases for a National Health Information Exchange. As discussed earlier, the use cases will be based from the primary healthcare workflow. So what is a primary healthcare workflow? So in a primary healthcare workflow, we have a patient feeling a symptom who will go to a doctor, a primary care doctor. The primary care doctor will examine the patient and will decide if the patient will need another referral to a specialist or not. So that will be the context of our use case. For the requirement, we will also discuss the requirement for a National Health Information Exchange in the Philippine context. Why did I mention that this is in a Philippine context? Because the requirement, which we will specify later on, came from our requirements gathering exercise from our own Department of Health. Next, we will discuss the architecture, in particular, the logical and the physical architecture for a National Health Information Exchange. So we have here the architecture for the Philippine Health Information Exchange. Most probably, you are familiar with the architecture because it basically follows the OpenHIE architecture. So we have the OpenHIE components at the top. We have the patient registry, the provider registry, and the health facility registry. We also have the shared health record, where all health records will be compiled. We have a National Health Data Reporting Registry, where all instances of particular diseases or instances of particular health information will be recorded. And then we will also have the health data standards terminology, or the terminology services. Below, we will have the edge systems, or the different IE applications, health IE applications that will need to access the data provided by our OpenHIE components. For them to connect to the various OpenHIE components, the various edge applications must first connect to the health integration module, or in our case, the enterprise service bus. So clearly, this is an example of the OpenHIE architecture. So we are now ready to discuss the use cases for a national health information exchange. So for the first use case, we have a patient who has already been registered in the patient registry. So the assumption is the patient already has a patient ID. He will come to the particular health provider, and then the health provider will send its patient ID to the enterprise service bus. So the goal of this use case is to validate and to get patient data. So the patient ID will be sent to the enterprise service bus. The enterprise service bus in turn will send the patient ID to the patient registry. So of course, if you are already familiar with an enterprise service bus, we know that the enterprise service bus may perform some actions on the patient ID data that was sent into it. It may format the data or validate the data. And then it will send the patient ID to the patient registry. So the patient registry, once it receives the patient ID, it will look for the patient. If it exists, it will send the patient data to the enterprise service bus. If it does not exist, it will return a response, a data not found response. Once the enterprise service bus receives the data or the response from the patient registry, it will again validate the data or transform it based on the requirements of the edge application, and then it will return the response to the edge system. So that's the first use case that we considered. So once the edge system receives the response from the enterprise service bus, it can now modify the data. Or if it didn't receive any patient data, it only received a patient not found response, it can create the edge system can create a new data, a new patient record that will register the patient to the patient registry. In any case, so once the edge system finishes in creating or modifying the patient data, it will again send the modified or the newly created patient data to the enterprise service bus. The enterprise service bus will, number one, validate if the received data came from a valid facility. So it will validate it in the facility registry. Next, it will also validate if the person, if the provider that sent the patient data came from a valid health worker, it will validate it via the health worker registry. And finally, once it receives validation from the facility registry and the patient registry, it will now send the patient data to the patient registry. In our use case, once the facility registry or the health worker registry does not validate the facility data or the health worker data, the enterprise service bus will automatically respond to the edge system indicating non-validation. It will only move forward to the third step, to the submission to the patient registry, once we receive a validated response from the facility registry and the health worker registry. Again, just to mention, there are also other processes that are being done inside the enterprise service bus. So we will mention later on when we discuss the functional requirements of an ESB. We will discuss those functionalities. Another use case that we are looking at is when a health provider wants to retrieve a particular health record from the shared health record. So in this case, the health provider will have a health record ID. So the health record ID will be sent to the health enterprise service bus. So the ESB may format the data, and then it will be sent to the shared health record. So the ESB will send the health record ID to the shared health record, after which the shared health record will either return the health record that is being retrieved or will return a data not found response. Once the ESB sends the health record, once the ESB receives the health record, it will then send the response to the edge system. So this is just synonymous to the earlier use case where the edge system will retrieve patient data from the patient registry via the ESB. For our next use case, we will now have a case where the health provider will add or modify a health record for a patient. So the edge system will send the health record to the enterprise service bus, and then, just like the earlier examples, the enterprise service bus will first validate if the facility sending the health data is a valid facility, so it will look at the facility registry. If it sends a positive response, it will then validate if the person, the health provider, is a valid health provider via the health worker registry. Similarly, if it sends a positive response, the ESB will now submit the health record to the shared health record registry. So we know that the shared health record is the repository of all kinds of health records. And then finally, the resulting record ID, which will come from the shared health record, will be appended to the patient data. So we are appending it to the patient data so that it will be easier for us to associate a particular health record to a particular patient. So this is this use case shows how to submit data to the shared health record and how to append it to the patient data. So the 4 use cases that we have shown are the 4 use cases that we considered in our prototype implementation. We will now discuss the functional requirements for the Health Enterprise Service Bus for the Philippine Health Information Exchange. Just to give a disclaimer, the ESB is a really powerful middleware tool and it has a lot of available functionalities. However, for the purposes of the prototype implementation, we are limiting ourselves to the following functional requirements. The requirements that will be mentioned and discussed are all part of the requirements gathering process that the team did with various e-health stakeholders. First, connection authentication. It is important that connection that the connections on the ESB are authenticated. The secure transport layer will be utilized both in connecting to the ESB and when the ESB sends out data either to the OpenHIE component or to the edge application. The ESB must be able to handle this authentication process. Next, data encryption and decryption. It is important that the ESB must be able to decrypt the data that is sent to it, and at the same time, it should be able to encrypt the data before sending it to the intended recipient. This functionality is important, especially for endpoints that are not utilizing secure transport layers. Number 3, content-based routing. The ESB must be able to process data based on its content. In particular, once an ESB receives a particular data, it should be able to determine which endpoint will receive the particular data. In content-based routing, the ESB will have one service that can accept any form of data, and that service will determine where the data will be sent based on its content. In our use case, the ESB has a single service that accepts patient data or health record data, but it is the ESB that decides on whether the particular data will be sent to the patient registry or to the shared health record. This increases the efficiency of the ESB as edge systems will no longer need to know where they are sending the particular data. The ESB will be the one responsible in determining the destination of the data. Number 4, data validation. It is important that the ESB must be able to perform schema-based validation on the data that is sent to it. It is useful as it lessens the possibility of error propagation because before the ESB will no longer need to forward erroneous data to the various registries, the erroneous data will be captured at the level of the ESB. Next, data transformation. The ESB must be able to transform the data based on the format of the receiving endpoint. If the receiving endpoint requires a JSON data or an XML data, then the ESB must be able to transform the data sent to it, either transform it to XML if the receiving registry requires an XML data, or transform it to JSON if the receiving registry requires a JSON data. So this functionality of the ESB allows it to accept any data, any form, and at the same time send the data based on the required format of the receiving entity. Next, data translation. Medical data in this different edge system uses different terminologies. So the ESB must be able to connect to a terminology service that will perform the translation of data based from one terminology to another terminology. Next, queuing. The queuing functionality of the ESB enables it to handle multiple requests at the same time. Data requests that are sent to the ESB will be queued until such a time that a server or a machine in the cluster will be able to process it. Several queuing algorithms can be used to efficiently handle this functionality. Finally, service orchestration. The ESB must be able to orchestrate services so that it can effectively handle the data sent to it. In our use case, we can see that once efficient data is sent to the ESB will first validate if the facility that sent the data is a valid facility. Next, it will validate if the health worker that sent the data is a valid health worker. And then it will only at such point where the ESB will actually forward patient data to the patient registry. In this example, the validation of the ESB of the facility and of the worker is part of the service orchestration functionality. If we will imagine without an ESB, an edge system will need to perform all the three tasks sequentially. So when we use an ESB, the edge system will no longer need to consider the two other tasks, but rather it can only focus on submitting the data to the ESB. These 8 functionalities are, in our evaluation, the most important functionalities that needs to be implemented in the prototype ESB. This functionality shows to the stakeholders the power of us. In this slide, we can see the architecture, the logical architecture of the prototype implementation of the Philippine Health Information Exchange. Take note that the architecture closely follows the OpenHIE framework or AeHIN. In the architecture, or in particular, the logical architecture, we can see the interaction among the different components and systems inside an HIE. So, at the top, we can see the HIE components. So the HIE component include the various databases representing the registries. In our implementation, we only considered 4 major databases: the health facility registry for the collection of all health facilities, the health worker registry for the collection of all health workers, and finally, the facility registry, the patient registry, which is the collection of all patients in the locality. In our architecture, we can see that there is a registry manager inside the HIE component box. So the goal of the registry manager is to allow the system admin or whoever has the access to add, edit, delete, or view data in our registry without passing through the interoperability layer. This is particularly helpful in the health facility and in the health worker registry, where there should be no access from outside connection. For the case of the shared health record and the patient registry, adding, editing, or even deleting data can be done via the services that will be made available to the ESB. Take note that connection to the various registries are done via web services. This allows us to protect the data inside the databases. For the health facility registry and the health worker registry, a single validate web service is made available. This web service will be invoked if the ESB wants to validate if a particular facility belongs to the health facility registry, or if the particular health worker belongs to the health worker registry. Another service that will be made available via the Enterprise Service Bus is the Add Edit Record of the shared health record, the Retrieve record, which is a shared resource of the shared health record and the patient registry, and the Append Health Record ID to the patient data service. For the Add Edit record, which is a shared record of the shared resource of the shared health record and the patient registry, the ESB should be able to send data, modified or not, to the patient registry or the shared health record. In the Retrieve record web service, the ESB must be able to receive either a shared health record if it sends a record ID, or patient data if it sends patient ID to the web service. We also have an Append Health Record ID functionality to the patient data. This is the scenario where a particular shared health record is associated with a particular patient. So take note that since we are using a service-oriented approach, the web services are kept optimal, and we would like to maintain as few web services as possible, with each web service being able to service multiple components at a given time. The Enterprise Service Bus lies at the middle of our architecture. So the Enterprise Service Bus is as we have mentioned earlier, has various functionalities. The first layer that will be encountered when we use the Enterprise Service Bus, when an edge system uses the Enterprise Service Bus, is number one, authentication. The ESB should be able to authenticate the connection, and number two, it should be able to decrypt the data sent to it. And then the various servers connected to the ESB will need to queue to a load balancer. Next, the data sent to it must be transformed to the data that is preferred by the receiving registry. And then finally, content-based routing is done. So based on the content of the data, the ESB will determine where it will send the data. And then the ESB will again authenticate the selection, the sending of the data. And next, it will also indicate that the ESB is secure. Upon response, so from the registry, it will again need to pass by the authentication layer. And then, since it is possible to receive multiple responses, The ESB will already correlate the response to make it easier for drivers and others who want to receive a single response. Finally, the ESB also has a data transformation service from the registry to the edge system, because the edge system may have particular data formats that it is requiring. The ESB is connected to the web management console, so this serves as the admin page for the ESB. And down below, it has a single send message API. The send message API contains a single function where a user will be able to send data. So, putting in mind the content-based routing functionality, the send message API is actually a single API that can be used regardless of the data. And once the data is received by the send message API, it will try to transform the data based on a format that can be understood by the ESB. So, and then down below we have the different edge systems. So we can see here the overall architecture of the ESB. Security can be found during authentication, during the invocation of the various web services, and during the implementation of the registry manager. For the next slide, we will now discuss the deployment architecture for the enterprise service bus in AeHIE. So as we can see, we have right now the three-level component that is similar to the logical architecture that we have shown earlier. So the edge system will connect to the enterprise service bus or the interoperability layer via an HTTPS connection. The ESB, if we will be looking from a physical perspective, is actually a cluster of servers where each server contains an instance of the ESB. We also have an assigned load balancer, so the purpose of the load balancer is to ensure that requests will be sent to available servers, or if there are no available servers, the request will queue in the load balancer. Take note that as we discussed in our earlier lecture, we have selected the SATO.io ESB, and the SATO.io ESB, if we install it, the assumption is it will be installed in the cluster of servers. Also, the SATO.io ESB has a load balancer application that can be used for the load balancer. So it's like installing a single package over a cluster of servers. So once the ESB finishes its processing of the data, it will now send the data to the registry. Again, the assumption is the connection here is via HTTPS. Take note that at the moment there are proposals to install both the ESB cluster and the registry using our own secured government cloud platform. In that case, the connection between the ESB and the registry will no longer need to be HTTPS. Basically, that is my discussion for today. Do you have any questions?
If there are no more questions, you can just email us through the Secretariat email at secretariat@aehin.org, and we'll be sending them to our speaker. Thank you for joining today's webinar.